Today we're going to divide monomials. Yesterday we were multiplying monomials. And when we multiplied bases, we did what to the exponents? We added. So guess what you're going to do if you divide the monomials? Okay, you subtract the exponents. This is called quotient of powers. When you're dividing two things that are raised to power, as long as it's the same base, okay, you just subtract the exponents. So a to the m over a to the p, you just subtract m minus p. So let's do the same thing here. Okay, g to the third, h to the fifth over gh squared. So I said you can, if you have to, write them out separately. I'm going to the first one, but I probably won't the rest of the time. I'm going to do g, and I'm going to do 3 minus what? 1. Okay, because g down there by itself is raised to the 1 power. So I do g, 3 minus 1, then I do h. It's 5 minus 2. So you can see what I'm doing. I won't ever write it like this, though. I will just go straight. 3 minus 1 is 2. 5 minus 2 is 3. So there's your answer. G squared h cubed. Here you've got k to the 7th, m to the 10, p, divided by k to the 5th, m to the 3rd, p. So I do k, and I do 7 minus 5. I'm dividing bases, so I subtract that. So 7 minus 5 is 2. 10 minus 3 is 7. What's 1 minus 1? 0. And I'm going to write this. This is not what you write, but I'm going to write p to the 0 power. Do we know what that is?
0.
No, it's not 0. It's not p either. Okay, because p by itself is 1, right? So p to the 0 power would be
Negative p.
it's 1. Okay, it's 1. So I don't write that. You write 1 in front, but I wouldn't. It's just I would get rid of p. That's going to come into play later when it's talking about getting the 0 power. Okay, you have to know anything raised to 0 power is 1. So there's your answer. All right, write this down. Here we call this quotient of a power of a quotient. If you're raising a quotient, a division problem, to a power, all this does is it raises everything on the inside to that power. It's just like when we were raising a power of product, we just raised everything to that power. Here we do the exact same thing. A is being raised in power, B is being raised in power. Write this down. So on the first one, I'm just raising everything to the second power. So I raise 3 to the second power, and I raise P to the second power. What is that?
1. So we can take.
No. What if I raise P to the second power? What do I have to do?
You have to subtract 3 and 2.
No, this is a power of a power.
Oh.
So I have to multiply. Okay, if I'm raising a power to a power, I multiply. And then I raise the bottom number to 2. So now I just simplify. I do everything I can. What is 3 squared? 9. And then it's p to the 6. And what's 7 squared? 49. 7 times 7 is 49. We just leave it as that. The book is fine with that as an answer. Okay, let's do the next one. We raise everything to the second power. So 5 squared x to the 10 y squared over 6 squared. Okay, sometimes a lot of people will forget that bottom number. You have to raise everything to it. So 5 squared is what? 25. X 10 y squared. What is 6 squared? 6 times 6 is 36. That's our answer. And that's it. All right, this is the zero exponent property. It's just meaning that any non-zero number, okay, as long as it can't be 0, you can't raise 0, 0. If you raise it to the 0 power, then it equals 1. That's all that says. So let's do this problem. Negative 4n squared q to the 5 r squared over 9n cubed q cubed r 7. Raise to 0 power. What do we get?
1.
There you go. Equals 1. Because everything's being raised to 0 power. None of these are 0. So as long as you can't raise 0 to 0 power. That doesn't work. But any non-zero number you can raise to 0 power, it equals 1.
Oh, what happened?
X to the 5th, y to the 0 power over x to the 3rd. What should I do? What's the first thing I do here?
Take out y.
Take out y. Y to the 0 power is what? 1. So I can write 1 or I can just leave it, right? I don't need it. So I just have x to the 5th, x to the 3rd. What should I do here? How do I simplify this?
Subtract 5 and 3.
Subtract. I'm dividing power or x bases, so I subtract the exponents. That gives you x squared. This is important. You need to know this. This is the negative exponent property. If you have anything raised to the negative exponent, that's why we've talked about it being not a monomial. Okay, because a negative exponent makes it a denominator. You can see here a to the negative n power is equal to 1 over a to the n. To get rid of the negative exponent, we drop it. If you flip it to the bottom. If it's already on bottom, you'd flip it to the top. But to get rid of the negative exponent, you flip it. If it's on top, you can make it bottom. If it's on bottom, you make it top. So here we have n to the negative 5th, p to the 4th, and you have over r negative 2. What's important and what you need to do is flip the numbers. For this, none of these are the same basis, so you don't have to do quotient of powers. You don't have to do, a product of powers. All you do is flip it. So I'm going to flip n, because n is negative 5th power. I'm going to flip it and put it on bottom, so it becomes a positive power into the 5th. P to the 4th, I'm not going to do anything to because it's already positive power. R to the negative 2, because it's already on bottom, what I do is I put it on top. That's what I mean by flipping it. The book, it just says make it a denominator, but in this case, you don't make this a denominator, you make it a numerator. You flip it. So wherever it is, you put it on the other side. This would be your answer here. P to the 4th, r squared over n to the 5th. Here's how that works. If you really want to know, let me give you an example. Let's do. These are. We could do this. Okay, let's do that over that. Okay. We know that is a quotient of powers. And what does this say to do? If I'm dividing bases, I do what?
Subtract.
So I subtract. What is 2 minus 4?
Negative 2.
-2, right? Okay. Well, let me illustrate these with just writing out the c. So c squared is c times c, right? And c to the 4th is c times c times c times c. I get rid of that one with that one. That one cancels out that one. So I've got 1 over c squared, right? Well, isn't that what I get right here? C to the negative 2? Yeah. Aren't they equal? Okay. Because c would be left on bottom, that's why if it's a negative exponent, you have to flip it to the bottom. Does that make sense for you? 2a squared b cubed, c to the negative 4. I've got 10a to the negative 3, b to the negative 1, c to the negative 4. So you can split it up. The book kind of splits up everything by parentheses. I don't really think of it like that. Okay, but I am going to rewrite this. Right, so I've got 2 over 10 a squared over a to the negative 3. This is when I'm dividing bases, I do what? I subtract. So I do I do 2 minus what? Negative 3. Be aware of that. Okay? If you're dividing by a negative exponent, you're actually just adding it. So b would be 3 minus what, Richard? 3 plus 1 or 3 minus negative 1. It's the same thing. Good. And then this one, right? The c negative 5. So I can just keep it as that and do minus negative 4. It's going to end up on bottom. But let's work this out. So 2 over 10. What can I reduce that to? 1 or 5. What's a squared plus, so what's 2 plus 3?
5.
A would be the 5th power. B would be what power?
4.
4. And C would be what power? negative 1, right? But do I leave it as this? No, I don't want to leave it as a negative exponent. So I do my 1 over 5. I do a to the 5th, b to the 4th, and I put c on bottom. So there you go. There's your, and actually the book probably won't even have 1 there. It's probably just going to be a 5th, b 4th over 5c. Any questions about that? Pretty easy, right? All right. Here's your assignment.